All right.
Cool. There you go.
Okay, so now we are live. Welcome, Peter. Um, and let me just do a couple things here. All right, good. So let me just uh, give a little of a couple of updates. Um, I posted in the chat. I'm not sure if people can see it who joined afterwards, but there's an article in today's Current about a uh, um, AI data center. I believe it's the one in Memphis, and it's worth reading. No surprise to I think people on this call, but the debate over AI data centers and nuclear power to power them is already in Connecticut, and we saw some bills raised last legislative session, which were debated. I have every confidence that we will see them again this session. Um, there's a lot of moving parts. Governor Lamont was I heard him quoted today. He wants to see more nuclear power in Connecticut. Um, thing, things are happening. Let me give a shout out to Jeff Gross. I see you there. Um, Jeff, thank you. You and Sierra Club had Chris Rivers on in May. I attended that, found it to be fascinating. And so, without further ado, the introduction to Chris. Chris has been around for the block in terms of AI and data sensors. And now, Chris, if I understand correctly, I'm just trying to remember that email. You are a consultant to for the world of AI and data sensors. If I have any of that incorrect, my apologies. And if you want to correct the record, feel free. But I'm assuming, Chris, you will do your presentation and hang out for Q&A.
Yep, absolutely.
Okay, good. Okay, so take it away then.
Awesome. Let me go ahead and get my screen shared. Can
All
everyone
right,
see the PowerPoint?
that looks good.
Okay. So before I get going, just know it is really creepy to make a presentation about AI using AI and having AI generate the images for the presentation about AI. It just still feels creepy to me. But there you have it. What we're really going to talk about today is the intersection between AI and energy demand. And why am I the one talking about this? So, my background, my professional background, has been quite an interesting journey. Grew up in Naugatuck, Connecticut, born and raised my entire life. First one in my family to go to college before going to study physics and nuclear engineering at West Point. I was an Army medic, fought in Iraq, and took my SATs in Kuwait, and then went to West Point. So I academically studied nuclear engineering as a minor as part of my undergrad experience. And at West Point, that was cool. They have their own subcritical nuclear reactor in the basement of one of their science buildings. And when you learn nuclear engineering there, you also get to learn all the weapon design stuff and it's more than just civil power application that you learn there. After my time at West Point, I became an Army engineer. I led about 150 combat missions in Afghanistan doing route clearance. Also learned all the normal Corps of Engineer stuff that we have to learn. And ultimately, the Army brought me to the Pentagon to be a data scientist, or what we would call an operational research and systems analyst. And that's when I decided to get out of the Army and I went to grad school at Georgetown. I got a master's in public policy and another one in international relations, and went to work at the US State Department where I managed all of our science relationships with all the countries in North South America. And while I will do my best to keep this presentation non-political, I left government service in the first year into the first Trump term because I just couldn't see where we were going, and it just wasn't the the direction that the administration wanted us to go just wasn't clear. And so instead of spinning my wheels in the administration at any level, I decided to get out and I got into consulting. And that's where I started really doing serious technology strategy consulting, first at Deloitte, and then I went to Infosys where I was doing AI strategy consulting. So the sort of business leaders have a business problem and they're just not connecting with the AI technologists out there. I would be the person in the middle translating back and forth often. And I did that all the way up until about a year and a half ago when I transitioned yet again into a different role. And my day job now is really a director of social impact consulting, where I'm working with the CSU, the public higher ed system here in Connecticut, mostly on system design, not anything on AI or energy. But all that to say, I really care about this topic because I see AI demands. We'll talk about that in a second. I also really deeply care about the environment. That's a dog of, or that's a picture of my dog Patty and I going for an early morning walk. We go to a different state park every day. And so it's kind of this area where I have a couple different passions in my life coming together. And I just think that we need to up the level of knowledge and the level of debate for how we're going to do this because we're getting to an interesting pivot point here pretty soon, and I'll explain what that is. So before, and by the way, none of this will be technical. You have to have zero technical background. We're going to cover this as though you have no experience in either energy or AI. So that's the level I kind of made this presentation at. In the world of AI, when you look out at the international systems zooming way out, you kind of have three approaches to it. One is what I call the China approach, where China really sees developing AI as a cutting edge technology and they need to win at all costs. And because in their governmental system, they don't really believe in personal privacy and personal data rights and anything like that. They're just using their billion plus population and all the data they collect from them in order to accelerate AI as much as humanly possible because they think it's part of a national security, long-term economic security play. On the other side of the spectrum, you have the European Union with their GDPR and their other public privacy data regulations. They have taken a much more, we want AI, but we only want it, we want to put guardrails around it so we don't have the sort of privacy intrusions and whatnot. And so they want AI, but in a certain set of terms. And the US has, interestingly enough, been pivoting back and forth between these two, where typically have been somewhere in the middle, where we have a couple data protections, mostly around financial data, data about kids, and healthcare data. And then we also have kind of expectations of what we want our big technology firms to do. And then the big technology firms lobby a whole lot in order to keep those at an absolute minimum, but we do have some. And again, not making this political, but going from the Biden administration that was going a little bit more towards the EU side of having data protections and having more guardrails in place than we had before. The Trump administration has definitely pivoted towards a we want to win this race. We don't really care what it costs, and we are going to see AI as a future for economic development and national security. The that kind of just sets the stage. And the other part I'll talk about is just AI is not new. The first models were really date back to the 40s and 50s, and the theory of it all dates back pretty far. And so when we kind of think back a couple years when ChatGPT really started making this on the tip of everyone's tongue, just know that the sort of technology that underlines it is not new, but the scale at which it is being implemented is truly new and breathtaking. So this slide is just really to back up what I was just saying about this Trump administration is really pushing both nuclear energy and AI. It is clearly a part of their overall approach that in order to have these AI models continue to grow, they need to get energy from somewhere. And their answer seems to be take all the regulations and reform regulations in our nuclear industry to an absolute minimum to make it as streamlined as possible. To be fair, some of these processes probably do deserve a relook. They're a lot of very old processes. We haven't built new nuclear power plants in a very long time in our country, um, at least not at scale. With that being said, I have certainly personal issues with the way they're going about it, but we'll talk about just the pure need. But this administration, between their AI executive orders and what they're putting into their legislative agenda and what they're doing from a nuclear perspective, it is just clear as day, even though this will not get very much in the way of news coverage. They are pushing nuclear energy as a way to meet the AI power demands. So why is this all important? And why is this different than what we've had before? There's basically, from a power consumption perspective, there are two ways that AI uses a lot of power. One is the training of AI models. So ChatGPT 3 feels like old news, but that consumed 1,300 megawatt hours of electricity just to train that model. And companies like OpenAI, while they're not all that open about how often they're training these models and whatnot, they always have these models in development and they're constantly retraining these models. The estimates for ChatGPT 4 was about 1,750 megawatt hours. So that's about 160 American homes worth of electricity usage just to train their model. And ChatGPT 5 is believed to be uh, much larger than ChatGPT 4, but we don't really have estimates for it. Um, the And that's just on the training side. And to keep in mind, OpenAI training ChatGPT is one company. You have Google and Gemini. You have Gronk on Twitter or X. You have Perplexity. You have a whole bunch of other AI companies that are all training their own models using a ton of electricity to train these models in order to be at the cutting edge over and over and over again. Then on the right-hand side, you have the energy consumption for actually using these models once they're already trained. So the training, think of it as you have a whole bunch of input data. ChatGPT 4 or 5 has about 1.6 or 1.7 billion parameters that they train, and then they produce outputs. And every time that we use the AI tool, whether we want to or not, that AI algorithm is going to basically go check the vast majority of those 1.6 or 1.7 parameters for everything that you search. So gone are the days of simple Google searching where they're just kind of looking for metadata in web pages. They are literally sending electrons and servers to check every parameter when you're searching it. So a single AI response will take somewhere between 3 and 30 watt hours of energy. So that's about 18 minutes to 3 hours for an LED light bulb to run for every time you're using AI. Multiply that by about 2.5 billion daily queries worldwide, and all of a sudden you're basically adding the equivalent already of 1.5 million homes to the US every single day for electrical power demand just from using these models. And I would say for those of us who wish we could just turn it all off, companies like Google are all just automatically giving you an AI response in addition to the normal Google search. Like it's just getting embedded in our daily apps. So it's getting really hard to opt out of. So what's fueling and how does this physically work? Well, this is where you get into the conversations about data centers because for these AI models to be hosted, they need to be hosted in these data centers for billions of people every single day to query. And these data centers are quite literally everywhere. In a really good book, The Empire of AI, they talk about data centers and really remote parts of Chile and other areas that are absolutely wreaking havoc on local economies. We have data centers all across the US. We have them here in Connecticut already. And there are definitely companies looking to build more data centers because for the AI tools to be able to be used at scale, they have to have the data centers. And the data centers really use two things, electricity and water to cool down the servers. They use that more than most businesses do. So, what does that mean for us collectively? Well, I'm sure this group knows pretty well that across the entire United States, we get about 21.4% of our current electricity generation. By current, I mean 2023 from renewables, about 18 to 19% is nuclear. We still have about 16.2% in coal, which really is irksome for me personally, and then 43-ish percent in natural gas. And when we look at how much energy we expect data centers to consume, currently we expect about an 8% of US power demand by 2030 is the absolute like lowest limit that most of the experts, economists are talking about for electrical consumption of data centers in the overall US consumption pile. But 11% is their bull case increase. And I'll get to more of that in a second. But at the end of the day, I really personally think that all of these estimations are dramatically undershooting the actual total electrical use that is going to go to AI. So the um and I'll get to that's really played out on the right-hand side here. On the left-hand side is sort of the history look at different energy production. So coal has been definitely on the decline since the early 2000s, which is good from an environmental standpoint. Natural gas has been certainly increased, but that is definitely more climate friendly than coal, but also very open to international issues like Russia invading Ukraine and all of a sudden sending natural gas prices through the roof. Uh, you also have the nuclear part has been really, really steady, and that's the area that has the largest ability to scale if the US wanted to build a whole lot more. And then you have renewables that between all the government programs has certainly been growing. But in terms of the sort of data usage of what we expect to happen with AI, the chance to really scale renewables just doesn't seem to be a real engineering option at this point. On the right-hand side, are different think tanks that are more from the environmentalist side, and their projections of what they think energy demand is going to increase because of AI. And so the Princeton one at the top is probably the one I would side more with. I really do think it's going to be an exponential growth, but everyone is expecting it to increase. So you're talking needing to find another doubling or tripling of energy demand for just the AI part of it. So we need to find a lot more energy, and the idea that we could do that through renewables is probably not the only answer, though it could be part of the answer. So that's why people start thinking nuclear, because the amount of energy you could produce in a small area, nuclear is really the uh, part of this conversation that a lot of people immediately jump to. The current state of energy production here in Connecticut, the consumption estimates are on the left, the generation by source is on the right. Largely from a source perspective, we have Millstone that produces a good chunk of our electricity, and then a whole lot of the rest of it is through natural gas. And we obviously have some hydroelectric, we have some other renewables out there, but by and large, here in Connecticut, and we don't produce enough power already, which is why I think you have state leaders looking at AI increases coming, and we're already not producing enough. And so, what does the answer become if you care about the environment at all? Um, is you kind of start leaning against that nuclear question. So then that leads, for me, the question to revisit is nuclear energy, good, bad? And here I just try to be really factual. On the pro side of the argument, it's clean energy, uh, as long as you manage the fuel and spent fuel appropriately. You create really good jobs when you have nuclear power plants. Here, I live in Eastern Connecticut right now, and Millstone hires a lot of folks that pays them fairly good wages. And then because we have, or we're making nuclear subs here in Connecticut, we have a good nuclear education pipeline here in Connecticut as well. And because we have that, we also have people that can manage things like our aging weapon design stuff and our ability to manage nuclear security issues around the nuclear side really depends on having a good education pipeline of nuclear engineers. And we have that here in the US. That's on the pro side. On the con side, people are really repulsed by nuclear energy. There's been a lot of famous incidents over the years, and I get that. Their fuel management, once the fuel comes out of the nuclear power reactors, they have to be stored for oftentimes over 10,000 years. And to put that in reference, like humankind as we know it has only been around for 10,000 years. So how do you store nuclear spent fuel in a way that's safe? For that amount of time is something we haven't really figured out yet. We, as a country, had a solution to put it all in one mountain, and then for political reasons that backfired on us. So right now, a lot of the fuel is being stored at the reactor sites themselves in safe and useful ways to store it there, but is not how the system was originally designed. Nuclear power plants are really expensive to construct. There's just no getting around that, and because of how expensive they are to construct, the actual price per kilowatt hour you get out of them is certainly not as cheap as natural gas most of the time or some other production options. and they're expensive to operate. You have to operate them safely. You have to have engineers. You have to have safety vehicles. You have to have a certain amount of oversight that a lot of other power plants, you don't necessarily have to have the same level of oversight. The other part of this is in the United States, our nuclear reactors and our nuclear industry is pretty old. The oldest nuclear power plant we have is 9 Mile Point, Unit 1 in New York, that went into service in 1969. And then the newest one went into operation in April 2024, but we also had a big low in a time period where nuclear power plants were not getting approved to go online. Here in Connecticut, Millstone, I believe the first reactor was completed in 1970, and it's scheduled for closure in 2056. That at Millstone, we have a combined generating capacity of 2,100 megawatts. And so if you look at, we're already not producing enough. Data centers are popping up. Even if they don't pop up here in Connecticut, they'll pop up in neighboring states. So we have a regional problem. And if we don't start addressing this now, then this kind of gap between demand and production is going to just keep getting harder and harder and harder. And I should note that the Atomic Energy Act authorizes the Nuclear Regulatory Commission to issue licenses to the commercial power plant reactors to operate up to 40 years, and then they could be extended or renewed for 20 years at a time. And that's what Millstone is coming up on, is already being extended. And so you're not going to get likely another extension after that. So why does it take so long to build new nuclear power plants? On the left-hand side is a comically simple approval route for how to approve a nuclear power plant. There's basically three tracks to it. You need someone to submit the license, you need to have a public hearing, and you need to have as many hearings as the local public would want. And the local public needs to be informed of what's going on. So you kind of have a public track. You have a safety track. So the company who wants to build a nuclear power plant would have to submit all of their designs, and these packets could be thousands upon thousands of pages long. And they get safety reviews from the federal government. There's public involvement in that as well. And they get a final safety evaluation report. Then you also have an environmental pipeline to it where that same company who wants to build a power plant has to do or sponsor environmental reviews. That gets reviewed at the federal government, and there's a final environmental impact study. And all three things have to get approved. It has to be approved from a safety perspective, has to be approved from the local public perspective, and it has to be approved from an environmental perspective. What does that mean in reality? The chart on the right, even though it's an international chart, I think it's really telling that it quite literally took one power plant in the US over 40 years to get approved. The normal timeline is 5 to 10 years. Uh, it is not uncommon for things to take 20 years to get approved. And the larger in capacity they are, typically the longer they take. So, all that to say, we have a power plant here in Connecticut that is scheduled to basically be retired in 2056. If we're not getting the conversation going now about what we want to replace it, whether it's a new nuclear power plant, even if it's in the same footprint or whatnot, you can't wait for a year or two before the power plant is going to go offline to start having this conversation. With that being said, I have zero idea of how all the sort of deregulation efforts of the Trump administration is going to impact these timelines. They could really speed up. The other thing that could speed them up is the idea that modular nuclear reactors could be a path forward. So that leads us to a question, what is a modular nuclear reactor or a small modular reactor? The difference between a typical nuclear reactor and a small modular reactor is basically one of mass production versus custom builds. A traditional nuclear reactor, how they all have been built in the US so far, is a company wants to build a nuclear reactor at Millstone. Great. Nuclear engineers, civil engineers, a whole bunch of other engineers come up with a literally custom proposal from the reactor size, type of reactor, though there's only a couple that we have here in the US, to the type of pumps being used, the cooling systems being used. There's a whole bunch of things that are very custom designed to Millstone. Each reactor gets designed in itself, and so it is a completely custom build, which is part of the reason why they're so expensive. So the idea in the nuclear industry globally is, well, instead of doing all these power plants as completely custom designs, what if we have quote unquote small modular reactors, in which case we're going to use one design that has a set amount of output which we can just build over and over and over again, the same way we kind of mass produce airliners. So Boeing has a standard design for aircraft. They can produce them in high numbers, even though they're super complicated. And because they could do that, you still have safety standards that the federal government can in theory regulate, and they can certainly get into trouble doing that. But in large part, we can make airliners super complicated, but we can make them quickly. And so, a small modular reactor, a couple different companies have designs, and they're not really that small, but they could be bigger or smaller. But you're still talking, you have a human there on the right to give you a sense of how big it is. But it's basically everything you need in a reactor from the pressurizer to the coolant pumps to the steam generator to the control rods to the core and all the components. You would still have to put the fuel in it once it arrived, but all the components are standardized. And because you would standardize it, the idea would be that you could use a lot more of them in a lot more locations. Excuse me. The thing to note about small modular reactors right now is it's a technology that is not proven and in development. They're, in theory, it all sounds great. The company in the US that has the lead is definitely NuScale. They have current licensing ongoing, so they're working with the federal government to get their designs licensed to be implemented. You can search on news. There's a couple different sites that are trying to move forward with it. There are only two small modular reactors that are operating anywhere in the world. One's in Russia, one's in China. They are government sponsored reactors. They are producing power, but they're producing power at a rate that is just not financially sustainable for anything other than government research. But this is sort of like anyone that looks at manufacturing companies, whether they're car companies like Rivian and Tesla or whatnot, whenever you start manufacturing something that's complicated, it's always going to be at a deficit until you make enough of them to get the cost of your manufacturing facility spread out across enough units. So there, Argentina has a unit being constructed right now, and Canada has a unit in design, and we obviously have a unit that's in the licensing phase. But none of these different designs are at all mass implementation anywhere in the world. So it's really an idea and theory in terms of a construction standpoint that still is not proven. Um, and most of these designs that you'll see, and you can Google small modular reactor, most of them are still in the conceptual design. They haven't even got into basic real designs, and very, very few are even in the licensing pipeline. So, with that being said, and totally fair to say, all of this is still very much in the theoretical stage. What are the major considerations for small modular reactors? One, economic development. You would basically be restarting an entire industry here in the US that has gone fairly stagnant. The modularity means that you can make them and put them where you need them. So the having them all as sort of self-contained units also means you can put, if Millstone was retiring a reactor, you could put several of these on Millstone and have it be able to plug into the electrical grid that's coming out of Millstone and replace the current reactors that are. Sorry. Um, sorry about that. You would see, let me drink a little bit more. I'll come back.
Yeah. Thanks, Chris. Take what time you need.
All right. Sorry about that. I'm also coming over a cold. We're near the end and we can get into the questions and answer here soon. Modularity means you can use it in a lot more sites than what we currently use our nuclear reactors in. You would, in theory, have a lower capital investment than a traditional nuclear reactor. You would open up a lot more sites to be able to put these in than a traditional reactor would be able to go into. You would, in theory, have greater efficiency in the overall industry because you'd be mass producing parts and could replace parts instead of having everything be one-offs. And then in theory, you'd have better safeguards and security, although that is debatable if you start spreading them out. Right now we only have relatively few nuclear reactor sites, so we can secure them really well. You start spreading these things out in a lot more locations, you definitely have safeguard and security concerns that you have to manage. The challenges for small modular reactors is because they're still in the developmental stage, they're not going to be cost effective compared to other forms of electricity for right now. That could change if thousands of these start getting made, but for right now, every one you make is going to be really, really expensive. Our licensing process is really made for these one-off designs that have engineer teams on the business side and engineer teams on the government side work together to figure out what the safest approach is. We haven't quite figured out how to harmonize our regulatory environment to really make the standardization work without absolutely declaring one business winner over others. And we haven't rejiggered the entire licensing process yet. You start adding more reactors to more sites. Right now, our power plants always have engineers and safety teams on standby to monitor them at all times. You start adding more modular reactors to more sites, that becomes harder. So you start having more safety concerns. The funding and interest, the Inflation Reduction Act, put a whole bunch of money through the Department of Energy into this research and also into fusion research. And while fusion sounds like it's a far off science fiction power or energy approach, we have been having breakthroughs in recent years. So no one really knows how far off clean nuclear fusion energy is. No one can predict that, but we are starting to have breakthroughs. And so the big question becomes when and if we should put a whole lot of money into other forms of electricity production or kind of put a whole lot more energy into fusion investment, which for this administration, putting a whole lot of energy into basic science research does not seem to be their forte. So we might be on pause for that for a little bit. And then finally, while the burning of nuclear fuel is itself considered green because you're not emitting CO2 and whatnot, you still do get to an end point where the nuclear fuel needs to be stored, and that is radioactive and is bad for the environment if it ever gets out. Now, the containers they stored in are incredibly safe. They are safe for the rest of our lifetimes and our children's lifetimes and whatnot, but it is still, you have to store that waste somewhere, and that isn't great for the environment. With that being said, the counter argument to that is we also have already produced a lot of electrical fuel. Technically, we just have them stored in nuclear weapons. So we have 5,000 nuclear weapons, only 1,000 or less would destroy all of humankind. You have nuclear fuel at in more than we would ever need, and we have to store that whether we use it in our weapons just sitting there or if we use it in nuclear power plants, we have to store it. We've already made that problems for ourselves. So coming to a conclusion, and we'll do question and answer because I went through this relatively quickly, is this is what AI thinks are the pros and cons of it. So I don't know how much you really want to put into that, but it's basically what we already talked about on the pro side. A small modular reactor can definitely build capacity quickly in theory. You could scale it up in theory, because you would have standardized designs. You could have passive safety systems in them with modern technology that is better than what we have right now. You can, in theory, have reduced construction time. In theory, you can have lower upfront costs once you scale. In theory, it would be much more sustainable, especially if you use the nuclear material we already have in weapons. And the other part of this, and the reason why renewables will be tough, is these data centers use so much power that they need a lot of it, and they need to know when they're going to have it. They need to have it around the clock. And our battery storage capability for the renewables, while it is more than good enough for most homes and even commercial uses, the the amount of energy that these data centers are storing, we just don't make renewable energy in most sources at a consistent enough basis around the clock to be able to really feed these data centers to feed these AI models. On the con side, it's going to take a whole lot of money. Um, there's regulatory challenges. The nuclear waste and storage part of this is real. The economic viability has not been proven yet. It is still very much theoretical, and there is going to be a huge public perception problem. Some of it is fair, some of it is not, but Just looking around at our politics today, it's hard to have nuanced conversations about anything, and this needs to be a nuanced conversation. So I am not really out here talking about this stuff to push people one way or the other. I'm really just trying to get the facts out there so people can make up their own minds. So with that, other than my coughing spit, any questions?
Hey, Chris, Jeff goes, there's a why data centers, AI has its own power characteristics, and that's interesting. Kind of similar to Bitcoin kind of things, right?
Yep.
Proof of work and other things, which is just inherently wasteful. That's built into its algorithm. Those are often located like far, far away, in some place where they can get cheap electricity because they don't send any data back and forth really much. But anyhow, in any case, it's much cheaper to send data back and forth than power back and forth. So why not just put a bunch of these guys up in, I don't know, Norway, someplace where there's like cheap power?
So they're also doing that, I guess would be my response to you is there are data centers popping up all over the world. There's data centers popping up. Um, as far as way with Chile, I think the what most of the big data companies, Microsoft, OpenAI, Google, et cetera, are really looking at right now are the sort of countries and locations that have good data pipelines because a lot of data has to flow back and forth to use a lot of these AI models um, at the scale that they're being used. And so you look at a country like Chile, and the US invested a couple hundreds of billions of dollars at least because we have a lot of microscopes down there that look at the entire sky. And so we have data pipeline that we invested heavily in there. And so they become an obvious candidate to put a lot more data centers in, and there are data centers going in there. With that being said, um, those are just big players. And you have Anthropic, you have all these other companies, just the amount of data that we are creating from all of this too is astronomical. So we
Sure.
basically double the amount of data humankind has produced every like 2.5 years. So you have to store the data for the models to run on too. You have the models that need to run, and then you have the productions of those also end up being data that have to be stored somewhere. And each individual search isn't that much, but added up a couple billion searches every single day, and it starts adding up pretty quickly.
Uh,
Uh, Peter, thanks. If and folks, if you could do the hand raise feature, I'll call on you. Peter, take it away.
Well, first, Chris, thanks for a great presentation. It was really great to hear it. I have a couple of questions, but I don't want to hog the Q&A space. I mean, I read something just recently that said that small modular nuclear reactors are like a 10-year solution to solve a 2-year problem. In other words, the problem is coming on very quickly. And that by the time that, even if modular nuclear reactors can solve their price problem and their acceptance problem and all of that, I mean, the need for data centers seems to be growing much quicker than the solution is growing.
Yeah.
So to me, the implication of that is that some other solution is going to come along or set of solutions before small modular reactors are going to solve the problem. But tell me tell me your point of view.
So my point of view is you're definitely not wrong. However, the more likely scenario, I think, is we are going to enter a state here in a couple years where we're all going to be experiencing dramatically increasing electrical costs. And then you're going to start seeing brownouts across the country because we're just not going to produce enough to be able to keep up with demand. And I think you'll see continued investments in renewables. I think you'll see as much investment in natural gas as much as you could possibly see. I think you'll see even some coal plants probably coming back online with this administration and how they're deregulating a lot of what has been regulated. Um, and even with all of that, you still won't produce enough. And so I think the sort of steam behind the small modular reactor movement will keep going, but we're going to have to get through a couple ugly years. And I think that will keep the pressure up on small modular reactors. And hopefully, well, not hopefully, if it's done right, and that's a big if, that you're still gonna have this problem 10 years from now. So it's not just a 2 year problem, it's a problem really in the next 2 years that will last for however long it will last for until we figure it out.
Thanks. I have another question, but I'm going to let Eric and others go first.
Thanks, Peter. Eric, go ahead.
Yeah, excellent. That was a fantastic presentation. Thank you. Um, let's separate out the power generation side from the cooling requirements from the heat that's generated in the data centers in terms of global warming effects. Are these things generating enough to make a difference, or is it lost somewhere way to the right of the decimal point?
I would argue it's lost somewhere way to the right decimal point, and here's why. While the data centers themselves will consume a lot of water and typically fresh water, that fresh water goes through a whole bunch of filters, and then they typically keep that water coolant system running. So it's not going to produce enough heat to really make a measurable impact. Certainly not in a time where we're all driving gasoline cars still and everything else.
Mhm.
But yeah, they produce heat, but the heat problem is really how much fresh water are they using that could also be
Okay.
used for like people.
So the greenhouse gas side is on the how is the electricity generated? That's where the concern comes.
Yeah, and that's a good concern, Eric, because I'll tell you, the it's funny. I think Elon at some point basically said, "Hey, don't worry, some local community, my data centers I have feeding that are trading Grok are all like carbon neutral, whatnot." And then he didn't have enough power, so he hooked up a bunch of diesel generators to his
Yeah,
data center and kept them
read
running.
about that.
That's what they're going to do to keep their models running and trading. And
Hmm.
there's other ways to produce electricity. You can have diesel generators in a short term, but that produces a lot of carbon footprint, and that's happening right now.
And he happened to not get building permits and
Yep.
just skipped all that part. Yeah. All right. Thank you.
Yep.
Peter, do you want to ask your follow-up?
Sure. So I'm interested in thermal energy networks, and those of us in the thermal energy network space look longingly at data centers and the heat they're giving off as a thermal resource. I'm not sure I've seen any reciprocal interest on the part of the data center developers, whether they have any interest in being thermal resources. Have you heard of any such companies or developers?
No, I haven't heard of any, but I think it's an intriguing idea that should be explored.
Well, in Bloomfield, Connecticut, a data center developer did a presentation to the town council there. And just by the way, I keep meaning to listen to that presentation because I think it would be kind of fascinating as to how they explain the data center and how it's going to work and be of benefit to Bloomfield. But I got in touch with some people I know there and said, I think you should insert into the conversation, since this is so early, that you would be much more receptive if it could serve as an anchor for a thermal energy network extending out to neighboring buildings. Anyways, I haven't heard too much back about that.
Yeah, it'd be interesting. I mean, I'm also personally a huge fan of geothermal energy for a lot of our buildings and whatnot. And it seems to me that if the data centers we are running 24/7 anyways, they could produce without having to drill down super deep or dig up a lot of grounds. Like there has to be an answer there. But I haven't heard data centers and data companies tend to be really secretive about what they're doing too and not wanting a whole lot of outside folks in. So I would encourage you to keep asking the questions because I really think there's a there.
Great, thanks.
Yeah. Um, Peter, a great question. Just something for all of us to keep in mind. The data centers are the profiteers here. I don't mean that negatively, but they're the ones that are going to be raking in big dough. So maybe the onus needs to be articulated to be put on them to do things for the community. So,
Yeah.
Bernie, I think you were next, then Diane, then Jeff.
Great. Well, thank you. Like everybody, I think this was, you opened my eyes. Thank you very much. I appreciate it. Just to follow on what Peter said, I also am a fan of geothermal, network geothermal, and I think it does solve a problem for the data center itself, which is cooling. So they can take all that heat instead of throwing it out as steam, they can put it in the earth. And if they play their cards right, they can sell it to schools and residential neighborhoods and make another buck. And I'll pick up on what Andy said. They are coming with bags full of money. And so there's an opportunity there. They can do stuff that we in sleepy little Connecticut can't do. And the other thing I think I'm piling in three questions there, but the timeline question is a big one. I really do think that take I understand the intermittency of wind and solar, but wind is less intermittent than solar, and I can't wrap my head around shutting down Revolution Wind and things like that. They're an order of magnitude cheaper than any and quicker than any nuclear option. So, just a couple comments there.
Yeah, I think those comments are very fair. I would also say on the sort of thermal sharing from data centers, it also will depend dramatically on every town and where the data centers are proposed to go and how physically close they are. I know I live next to Basra. They had a data center the town ended up rejecting, but that physical location was never going to, it just wasn't anywhere close to any other building it could have used it. It's in the middle of a whole bunch of farms. But certainly should still be explored. And I agree with you. I don't take anything I said here to say that the wind projects that are ongoing, any of the renewable big projects that are ongoing, they should all continue to go.
Yeah,
We need, my personal perspective here is we are in a position where we need to make as much electricity in however is most beneficial to people and also least harmful on the environment as we possibly can. We need more than what we could produce now already here in Connecticut. We need to figure out ways to produce even more. And if we want to be able to leverage these AI tools, which aren't all bad, even though not every AI company I'm not a fan of, uh, but the opportunities AI to have medical breakthroughs and whatnot are also something we want. So we, you know, in I ran for the state legislature a couple times and came up a couple votes short, but I was always struck at how much all of our debates are all one or all the other. And like the answer is like we need to produce a lot more and we need a lot more sources to pull it from.
yeah. Thank you.
Yeah.
Thanks, Chris. Thanks, Bernie. All right, Diane, furtively traveling along around in a parking lot. We'll go until the agents find you, Diane, and then we'll think
Tell them where
kindly of you.
I am. Well, first of all, Chris, this was fantastic, and thank you for your service. And I'm so happy you started out with telling about your journey to this point. Um, uh, there were two things I wanted to see if you have insight on, and also maybe books or articles. And the first is, um, I believe there is many years ago was kind of quietly a data center was placed in East Norwalk, Connecticut. I live in Norwalk, and very quietly installed. The zoning commission didn't, no one really spoke about the pros and cons of the energy use and the water use. What I am interested in, though, in my field of work, I'm an environmental scientist, and that is if you could comment on incidents where the use of the fresh water has become an issue. And because of that, what, if any, zoning regulations or ordinances that you would recommend, or if you know of any in particular towns or countries that protects drinking water sources because of extreme weather. Right now, hasn't rained in a while, really, I live on the coast. I would be very interested in that. The freshwater use, what issues have occurred because of it, and also zoning, model zoning regulations that could help us should in any state that we move to, or Canada, if some of us are going to Canada soon. Thank you.
Yeah, so unfortunately I don't have off the top of my head, I don't have any real model zoning regulations pointing to, but let me do some searching and find out. I often find that uh oftentimes states like Arizona actually have a lot better water regulation zoning rules than we have here just because they live in a desert and they have to manage it, and some parts of Southern California are in the same boat. Let me do some research and I'll do some digging and I can get that answer to Andy and he can get it to you if that works for
Yeah.
both
Thank-
you and Andy.
Great, thanks.
Yeah.
Diane, great question. Chris, I just want to say I appreciate you acknowledging that you don't know all the answers. And so for everybody, these questions that we have, that Chris is not able to answer, and I'm not trying to put that all on you, Chris, just,
Yeah.
I don't know the answers to them also. Another way I would frame it is like, hey, we've had a couple of drought seasons in Connecticut. If AI comes and they're going to take lots of water in a severe drought situation, who has priority? We humans who need to drink water, or the AI facility that needs to use it for cooling? Again, Chris, I'm not going to put you on the spot for the answer for that, but I would suggest for all of us, if it comes up in conversation with any elected official who has any sort of cognizance over a decision for AI, that question needs to be addressed. And it's not something that can be pawned off if it's coming up for a vote in, for example, the legislature to pass a bill or to oppose a bill or whatever. That's a question that needs a solid answer. Sorry for the rant. Jeff, followed by Eric. Jeff, you are on mute.
Thank you. Yes, thank you for that discussion, Andy. I had the same question. I've never come across an IT solution, and Chris, you've been consulting a long time, that so dramatically has ambitions higher than the society can support, right? The regular computer data center is not quite like this at all. So, but one possible hope is either the market crumbles because these guys are not making money yet, and stock market's talking about this already, of course. But the other approach is, what if there were a radically more efficient way of doing this? And if we're talking about
Yeah.
basic research for fusion, I think we should look at basic research for this kind of computation. Have you heard about anything like that?
So there's a couple interesting thoughts here, Jeff. One is uh, I think we all saw the headlines about DeepSeek, of like them being 30% more efficient at the same scale. That is still a bit out there to be, I don't know, you can be on either side of that, whether that's true or not. Um, the other thing, though, I think from an AI perspective, is the AI industry went to these super crazy large models because they thought they were racing each other. You can have AI and smaller language models that are
Yeah.
also deeply well trained in just smaller niches. So let me put this in context. The large language models of ChatGPT that OpenAI is creating and Anthropic is creating and Google is creating and Microsoft is partnering with OpenAI to create. It's almost like if you took a human being and put them in the middle of a library with all of human knowledge and they got to read every book and memorize it and then you get to ask them questions. That's basically what they're training. There's no reason why you can't find usefulness in AI models where you only feed them surgery textbooks
Yeah.
and they're even more useful. And you can do it in multiple different languages, and you don't need to have the sort of crazy power draw in order to train smaller models. So I think what you're likely to see, and this is not financial advice to invest in or anything like that, but I really think there is an AI bubble. I think all these companies just started drinking whatever and just started getting to scale like faster and faster and faster. And it was very like it's good from a wow perspective. Wow, look at what ChatGPT 5 can do that we never thought AI would be in a position to do. But it doesn't mean it's the most useful approach to AI. And I honestly think I don't think this federal administration is going to be deregulating AI anytime soon, but I think if you want guardrails around AI, encouraging companies through tax systems or other things to say, if you really want to go full universe, big AI models, then you're gonna have to pay a debt back to society to make sure our electric rates don't go through the roof and whatnot. And I saw one of the chats about the water, just to circle back to that. Water used in cooling systems and data centers is still usable afterwards, generally speaking, unless something goes terribly wrong inside that data center. You can also design data centers, and I'm not an expert in data center design. you can design them where they're closed loop, kind of like you have geothermals for houses. Like you can have cooling systems that cool off and they just keep using the same water over and over and over again. So there are different designs for different data centers that are in use. I don't know what all the current designs are here in Connecticut, but you could regulate that. It just, once they consume a certain amount of water, they basically use that water for a long, long time. So that's another approach.
Thanks, Chris. Eric, followed by Peter.
Yeah, Chris, are you familiar with the incentives that Connecticut put in place for with tax abatements in off of property taxes in locales for data centers?
Yeah, my understanding is it's kind of up to the town to decide, and they get up to a certain amount. And
Hmm.
uh, because of the physical footprint of data centers and how most property taxes are calculated, they basically get a reduction. And then in return, because the data center only has a handful of employees at any given time, you're not adding a whole lot to the infrastructure of the town, other than the whole electrical and water demand.
Hmm. So, have you seen these in other parts of the country? Is this a, do you have opinions on how wise this approach is? Should we be trying to attract them or not?
So yes, it's commonly used in other parts of the country. It's commonly used in other countries. There's a lot of tax incentives to get businesses like this in because um, from a pure town perspective, especially the smaller, more rural towns, um, one data center can cover half of their town expenses, which for
Yeah.
people who are out in farming communities and whatnot,
Hmm.
that don't worry about water consumption because they all have wells and everything else. Other
Hmm.
than the electrical part, like it could make sense to attract data centers to a lot of our smaller towns that are struggling to keep up with basic expenses of running towns and schools.
Hmm.
With that being said, I also think a lot of the data centers come in and try to strong arm the towns
Yes.
and try to win over a whole bunch of selectmen who may not know all the facts. They try to get it through and don't want to answer public comment and whatnot. So all that to say, I think there are deals that could make sense. Not everyone is going to. Um,
Hmm.
Whether or not we should be actively trying to recruit them here, we have 169 different towns. Every town's in a different situation. I don't think we should forbid them from being here, but I think it has to be a good symbiotic relationship that works for everyone. And if bringing them to your town means that you're gonna have to pay a lot more in electrical rates, then probably not. But if you're an Eversource customer, you're gonna have to pay a lot more no matter what you do, and like they can pay for half of your town, then yeah, probably it's probably a good idea. So
Okay.
the devil's in the details, I guess, is my
Yeah, of
answer.
course. Yeah. Yeah. All right. Thank you.
Yep.
Peter, your hand went down. Do you still you got a follow-up?
Well,
Go
I,
ahead.
I always have a question. But
True.
I see we're very close to 7:30, so I'll be quick. And if there's not enough time, we can just forget about it. But it seems like one approach to solving this issue is that data. And I've read about this a little bit. That you know you ask a data center if it's going to draw electricity off the grid, that they have to pay for the infrastructure upgrades.
Yeah.
And I think that one of the problems with that, from their point of view, is it's really expensive. So they're looking at dedicated power sources. And I'm just wondering, in general, have you heard about state regulatory commissions, utility commissions, or legislatures imposing that upgrade requirement, that upgrade responsibility on data center developers, or um, yeah, or are things going in the direction of dedicated electricity supplies, whether it's battery electric or natural gas, more likely?
I think so. The short answer is across all 50 states and across multiple countries I've been tracking, there are definite different ways of passing on the upgrade cost to all sorts of businesses, to include data centers. With that being said, data centers are always going to try to pay the least amount of anything they can pay. Most of these data centers are also sort of third-party businesses. They're not the Googles of the world. Some are, but most are these sort of third-party data centers. So they're really running like medium-sized businesses. So they're trying to minimize costs. All that to say, I think Um, if you pass along the upgrade to them, then you're really going to push them to try to co-locate where the power is being produced, which on one hand makes sense for, whenever you produce power in one spot, like Millstone over here in Eastern Connecticut, gets spread out to a good chunk of the state, you lose some of the electricity that you produce just in transmission. So if you're going to have large consuming industry, putting it near the uh, spot it's being produced makes a ton of sense from an engineering standpoint. The flip side of that is, and I know there's a proposal to put a data center right next to Millstone, which from a pure engineering perspective makes sense. From a customer perspective, really doesn't, because they're going to be now the priority for all the electricity coming out of Millstone, and that's just going to mean all the electrical rates are still going to go up. So I think, some states like California and some other heavily regulatory environment states have interesting ways to pass on the sort of societal costs without it being direct one for one. So, here in Colchester where I live, we can't even put solar panels on top of our school roofs because our entire electrical grid would have to get upgraded in order to be able to handle it. We, as a town, can't afford that. Um, Now, if that cost could get spread over every business and municipal building that would benefit from an upgrade in the grid, then we could all of a sudden afford it. So the short answer, Peter, is there are definitely ways to make it work, but asking an independent data center to pay for the entire upgrade from the source of where the energy is being produced all the way to them is probably going to kill most of the proposals out there. And if that's what people want, then that's one way to kill it. But we probably need a better way to spread that cost out across more businesses who would all, by the way, benefit.
Right. Thanks.
Yeah.
Any other questions for Chris as he's on his deathbed? Chris, could you just sum up for me? Because I'm not sure if I get this.
Yeah.
What is the value of a data center?
So the
Like
value of
to like
having,
to me, like
yeah.
what is it to Elon Musk, and what is it to just Andy Bauer, regular schmoo?
So for the companies to be able to do what they're doing, it's invaluable. You have to have the data stored somewhere. You have to have a place where your models can run nonstop all the time. For you, the end user, there are really two benefits. One, having data centers near you means you have a lot less drop in data packets and whatnot that you largely don't notice right now because we do have data centers all over the place. Two, having the data centers in the US means that US law protects that data. So, in other words, if we, in theory, and we love to do this in the international relations community, if we got rid of all data centers in the US and just said we want all of our data centers to be overseas somewhere because we don't want to pay for the power, whatnot, we could, in theory, do that. But then every time your data crosses an international boundary, now your data is all of a sudden subjected to that country's laws. So I'm sure everyone here has data that is stored on data centers in Canada and Mexico and all over the place just because of how the big tech industry works. But if you all of a sudden start having data centers in the UK and Europe, which we have fiber optic pipelines to, or be all over the place, then you would start to see uh, lag in bringing all your data together. So every time you click on your Gmail, like your header could be stored in some area, subject could be stored in another area, the body of the email could be stored in another area, and because it's stored in different areas coming all to you when you click on it, it happens a lot faster. So you don't notice any lag whatsoever.
Okay, thank you for that. So I guess that leads me to another question, um, which I would recommend people keep in mind should it come up, should you're talking in a formal environment. How is my data protected? And again, not meaning to jump political, but we have seen moves by our president to acquire data, to acquire personal data. And so, taking Chris, what you said at face value,
So,
data centers, good for certain businesses. Okay, better in the US, I guess. Now convince me, policymaker, that a U.S. data center, you as my fellow, countrymen, countrywomen are going to protect me better than Mexico, Canada, China, or Russia. Again, not meaning to you to answer that question twice, but something that I think is a legitimate question to policymakers.
Andy, can I give you my political answer?
Go for it.
I gave you my engineering nonpartisan answer. My
Yeah.
partisan political answer is I think we in the US are due for a new era of consumer protection. The laws that keep our data safe are laughably and tragically antiquated. The fact that our data is only protected if it's financial data, which really isn't that protected, health data or data about minors, which is why like it's hard to get data about kids that are not your own kids in school and whatnot. Those are the only three protections we have, and that all comes from like laws that were date back to the 1917s, like or the early 1920s. We haven't rewritten those laws. We haven't because the big tech industry is the largest lobbying industry we have in this country. We need a whole lot more policymakers, both at the state and national level, that understand technology and can actually write some laws and actually balance the business interests, which there are a lot of, and the need to protect people's data. But that's not going to happen in this administration.
No argument here, but still another great question that
Yeah.
demands an answer. Um, Okay, so Chris, we're going to wrap up. Let me just say once again, thank you for coming on. It's great to hear you again because now I feel like I know I'm a little bit more comfortable with this, and I would suggest to everybody, Chris is probably 20 times more knowledgeable than your average policymaker on this. Those of you on this call, having heard everything, we're probably 3 or 4 times more knowledgeable uh, about this stuff than your average lawmaker, which should be a concern for everybody. As I said at the beginning, we'll most likely see something concerning AI and data centers in Connecticut this legislative session. And I'm not suggesting no to data centers, but I think we've generated a list of legitimate questions about their installation, their use, their environmental impacts. So as you guys know, this has been recorded. I'll send the recording out. The AI transcript. Well, it took me about an hour to correct the AI transcript just from the steering committee meeting 2 weeks ago. So I am going to give it my best shot about cleaning this up. Chris, I will include you in on a copy if you have time to look it over. Specifically, if I get something wrong, me and my AI overlord, then feel free to correct the record. But all right. So thank you, Chris. Thank you, everybody, for showing up. And any last minute questions or thoughts? All right. We'll leave it at that then. Thanks, everybody. Have a good night. Chris, once again, thank you so much. Take care, all.
Thanks, Chris.